Math through the ages, a general history for teachers and learners. Today we'll finally be talking about the math sketches. And I know I already explained a little bit of it in the history section of the series. I'm really proud of those two videos, by the way. But I have to explain the math anyways, so let's get this started with... Alright, let's go. Keeping count, writing whole numbers. Tally marks. That's about it. We just do tally marks. And then we eventually upgraded to symbols, whether it's 1, 2, 3, or however you read this. And nowadays we use the Arabic system. Alright, and then of course I already explained to you reading and writing arithmetic, the basic symbols. We go ahead and learn about basic symbols, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and we learn how to do math with them. 1 plus 1 is equal to 2, or for some reason, 6. Figure out this riddle yourself. I'll tell you the answer at the end of this video. And then we even have the basic symbols. Back then, of course, we only needed 1, 2, 3, 4, 5, and, well, yeah, nothing becomes a number. Of course, nothing had to happen. Like, you're like, how could nothing be something? People were like, how could nothing be something? But then, like, nothing itself as a word is still something. So we eventually just added 0 as a way to put it in, because until then we just use we don't even use placeholders. Like if you want to write 101, you would just write 1, 1. And how would you write 1001? You would just put in, you would just destroy the zeros. But unfortunately these look exactly the same, or at least similar enough that you could confuse them with like each other. So they invented a 0 to go ahead and place a placeholder there. And this was apparently very much more efficient than like writing 9 plus 1. Or whatever they had for a substitute for 10. Why 10? Why base 10, you ask? We have 10 fingers. Get it? And as a result, we made 0 a number. And then we have to write fractions. Fractions themselves, like parts of it. Like one of the most modern day examples is like pizza. Divide the pizza into 8 equal parts. Take out 1 slice. How much of that? What is that slice? Well, there's 8. We have 8 slices now. We only take 1, so it's 1/8. And, well, decimals aren't the same yet, so we're stuck with fractions. But fractions can only be rational. If you can write a decimal as a fraction, that means that that number is rational, not irrational. We'll talk about that later. And right, fractions themselves would become one of the most basis of things as well. Also, the Egyptians used this complicated system of fractions. Like, if you wanted to know what let's say 127 was, you'd be like 1/3. Divide that by 3. Then divide that by 3. That's how they wrote 1/27th. And, well, nowadays we just write it the conventional numerator-denominator way. And then, less than nothing, negative numbers. If you're familiar with the negative 9, you know, like if you can go in one direction, you can just go in the other direction, starting point being 0. This being the positive numbers, this being the negative numbers. But of course, at the time, we literally had no idea. We couldn't comprehend the idea of negative numbers at all. Like, okay, we made nothing something, but less than nothing? Huh? Alright, here we go, so... Negative numbers became a thing. At least they existed in one way or another. Like the only times people really used a concept of a negative number was like, I owe you money. Like, hey mom, I owe you $5. Then I will be like -$5 in my bank account, because unfortunately now I am in debt. Luckily, I got 용돈. So, yeah. Back to 0. It is. Translate that yourself. And then you got less than nothing, and somehow negative numbers became in existence, and as a result, -1/2, we started thinking of irrational numbers. But before we had to go to irrational numbers, we needed to create decimals, and this is where bitens and tenths came in. This is where we're all like, hey, wouldn't it be like sometimes just easier to write 0.1 times like 0.0001, this little decimal place, making like a fraction into a long digit number. Like, you just have to write a digit. You don't even need to write this kind of fraction monstrosity. Unfortunately, this didn't exactly create the cleanest solution. Like 1/3 would be like 0.3 with repeating 3s. 2/3 would just be 0.6, and repeating this little dash was standardized as the way to show that you're repeating. You're repeating the 6. And as a result, decimals were born because they made life a little bit easier. Even if it meant that we got monstrosity like 3.141 and so on. And now that we got that out of the way, we can finally talk about pi because, well, yeah, pi. Pi is, well, this. Have fun reading it. And even this isn't exactly all digits of pi. We were able, the biggest digit that we were able to calculate was 300 trillion. And that was a world Guinness record, and they achieved this on April 2nd of 2025. Very recent. And yeah, that ended up being one of the greatest things ever that ever happened to me. Memorizing pi is just not worth it, unless you want the Guinness World Record. And how you calculate pi itself was an interesting story as well, too. Like, there was this mathematician who, while before the era of computers and while they only could do hand, he went ahead and calculated 707 digits of pi. Which was only accurate to about 527 digits, because after that it inaccurate. He made a mistake, and well, everything else after that fell apart. Also, somehow he got 3 of the digits after 527 correct, but that was probably just out of mere coincidence. As a result, we were able to get pi, and the most accurate version of pi ever, at least at the time. This was 1812. After that, we went ahead to figuring out what pi is. We started learning about algebra. We introduced x, y, and z, which traditionally became the unknown values, and a, b, and c as the constant values that we could replace with our known values. And algebra was born. Then we would start thinking about linear thinking, solving first-degree equations like, y is equal to x plus b, and then you could go ahead and graph that on a coordinate plane, or a Cartesian plane if you want to become fancy. And then you go ahead, we found out about quadratic equations. We just upgraded the x to an x squared plus x plus, let me just change it to 2x plus 1 is equal to y, and then this is like x plus 1 times x plus 1 is equal to y. So essentially it's this, where it touches the x-axis at -1, and then it touches the y-axis, crosses the y-axis at 1. And that's where quadratic equations started coming in. Then we started solving cubic equations, and we had that fun math duel I told you about in the last episode. The history episode, that is, I'm talking about. Then we talk about Fermat's last theorem, which is something I didn't mention, but I'm not going to mention now because I barely understand it myself. Then we have Euclid's plane geometry. I have to admit, I kind of forgot to talk about this when I mentioned the history section of it, but it wasn't exactly the most important thing. Euclid itself is important, but I'm mentioning him now, so good job towards Euclid. He went himself and talked about plane geometry, where you put a plane through a 3D solid, and then you take away the extra stuff that doesn't cross the plane in the 3D solid, and then boom, you got this as your plane geometry. It was awesome. And then we had the Platonic shapes. I think you're gonna figure that out yourself. And this is the thing that the Greeks made, and they were like, alright, tetrahedron, fire. Was it fire? Yeah, tetrahedron, fire, cube was earth, and then other stuff as well too. And it's like those shapes, those 3D shapes, where they use the equilateral equal shapes, like equal polygons, to go ahead and create these shapes. Usually it's triangles or pentagons. And that is it. That is all the sketches that I'm going to talk about in a nutshell in this video. I know, very brief, and you probably will hate me for not explaining the math longer, but don't blame me, I'm not even a high school student yet, and don't blame me, I haven't learned most of this yet. Sure, I learned most of this page, but next time will be a very big killer. I recommend this video for primary or middle schoolers. Primary schoolers in Asia definitely will understand this, probably. Middle schoolers everywhere will probably understand somewhat of this, but I highly recommend the next part of the video, the second part, for high schoolers. So I hope you guys enjoyed this episode. I hope to see you guys soon. Until next time, Shihana. Peace. Bye bye!